In this video, we are going to solve example on inverse Fourier transform. So, to solve inverse Fourier transform, we need to make use of partial fraction expansion. So, the given equation is 6j omega plus 16 upon j omega square plus 5j omega plus 6. So here first of all check the degree of numerator polynomial and denominator polynomial. In this case, degree of numerator polynomial is less than degree of denominator polynomial. So in this case, directly go for partial fraction expansion. Now, to apply partial fraction expansion, we need to find out the roots of denominator polynomial. So we have a simplest way to find out the roots as first term will be as it is, split up the center term in such a way that its addition will be 5 and multiplication will be 6. So here we can split up this term as 3j omega plus 2j omega. So 3 plus 2 becomes 5 and 3 to the 6. So the last term is 6. Now from the first two terms in the denominator, we can take j omega common. The remaining term is j omega plus 3 plus from the next two terms we can take 2 common and the remaining term will be j omega plus 3. So ultimately our x of omega will be 6j omega plus 16 divided by, now from these two terms we can take j omega plus 3 common and the remaining term will be j omega plus 2. So here we have obtained the roots of denominator polynomial. So apply partial fraction expansion. We get 6j omega plus 16 divided by j omega plus 3 j omega plus 2 is equal to, here we have two roots, so there will be two constants. So a upon the first root j omega plus 3 and b upon j omega plus 2. So simplify it further. 6j omega plus 16 upon j omega plus 3 j omega plus 2 is equal to, so cross multiply it, whole divided by the roots j omega plus 3 and j omega plus 2. So here both sides, the denominator terms are same, so we can cancel it out and we get 6j omega plus 16 is equal to a j omega plus 2 plus b into j omega plus 3. Now from this equation we need to find out a and b. So to find out a, we have to substitute j omega in such a way that the second term becomes 0, so b becomes 0. So we have to substitute j omega equal to, so we want this b term to be 0, so j omega should be equal to minus 3. So if we substitute it, we get 6 into minus 3 plus 16 equal to a into minus 3 plus 2 plus b into 0. So we get 6 3s are 18, it is minus 18 plus 16, it is minus 2 is equal to minus 3 plus 2 is minus a, so a is equal to 2. Similarly, to find out b, we have to substitute j omega equal to, Now to find out b, we have to make a equal to 0. So substitute j omega equal to -2. So we get 6 into -2 plus 16 is equal to a into 0. So -2 plus 2 becomes 0, plus b into -2 plus 3. So 6 2s are 12. It is -12 plus 16. So it is 4 is equal to 3 minus 2 is b. So we get b equal to 4. Now if we check the partial fraction equation, this particular equation, so our x of omega will be equal to a upon j omega plus 3 plus b upon j omega plus 2. So in this case a is 2, j omega plus 3, and b is 4, so it will be upon j omega plus 2. This is our x of omega. And now we are supposed to find out its inverse. To find out inverse, we have a standard identity. So we have e raised to minus at u of t, its Fourier transform is 1 upon a plus j omega. So using this identity, we can easily find out the inverse Fourier of the above equation. So take inverse Fourier transform on both sides. So x of omega becomes x of t is equal to 2 is the multiplying factor, so as it is. So 1 upon a plus j omega. So a is 3 for the first term, so it becomes e raised to minus 3t u of t plus, for the second term coefficient is 4, and 1 upon 2 plus j omega. So a is 2, so e raised to minus 2t u of t. So this will be the inverse for the given example. So it is simple. First of all, from the given equation, find out the roots of denominator polynomial, but be sure that degree of numerator polynomial is less than degree of denominator polynomial. If this is not the case, if degree of numerator polynomial is greater than or equal to degree of denominator polynomial, in this case you have to do division and represent your answer as quotient plus remainder by divisor, and then apply partial fraction expansion. So you have to repeat this division. So divide the numerator polynomial by denominator polynomial using normal division, and continue the division until the remainder polynomial has a degree less than the divisor polynomial, and then apply the partial fraction expansion. So here the degree of numerator is less than the degree of denominator, so straight away we have found out the roots of denominator polynomial and applied partial fraction expansion. Then we have obtained the values of a and b, and then using the standard results we have taken the inverse Fourier transform.